Hello again. So in this video we're going to look at solving simultaneous equations graphically. Now in a previous video we've done this algebraically, so this is now using straight lines and finding where they cross, because where the lines cross is your solution to the pair of simultaneous equations. So here goes. We start by looking at the first equation, so this one here, and we're going to do what's called the cover-up method. So what we are going to do is we're going to cover the y in this case. So we're saying here, let's assume the value of y is 0. If that value of y is 0, what would the value of x be? Well, hopefully you can see that x would equal 5. 5 plus 0 is 5. So we're going to use a coordinate here where we said the value of the y was 0 and the value of the x in this case is 5. So we've got our first coordinate for this straight line, 5, 0. 5 across, 0 up is just there. We do the same thing again, apart from this time we cover up the x. So what we're doing here is actually making x equals 0. Cover up the x. What's the value of y? Well, y is clearly 5. So in this case, we have got 0 across, 5 up, and that's our second coordinate. 0 across, 5 up. Because we know it's a straight line, we can just draw a line between those 2 points. There's the first one done. So we did the same with the second one. We're making y equals 0, so we cover the y, and now we've got 2x is equal to 6. So now we solve this. Divide both sides by 2, therefore x is equal to 3. So we've got a coordinate 3 comma something. Well, that something, if you remember, was 0 because we made that y equals 0. And there's our first coordinate, 3 across, 0 up. Our second coordinate is we're now making the x equals 0. So 2 times 0 is 0, so that we're covering that up. Now y is worth 6. So that coordinate is 0 comma 6. There we go. And the solutions are where those lines cross. So the solution to these equations is here. So what we do is we look at that. Well, that coordinate is 1. Sorry, that x coordinate is 1 and the y coordinate is 4. So you're just looking down and across. So we can say the solution is x equals 1 and y equals 4. And that's our first one solved. So let's look at another question. Same principle here. We're going to start with the top equation. Again, we're going to make x equals 0, so that's 0, and y equals 4. So our first coordinate is 0, 4. And now what we are going to do is we're going to make the y equals 0. So we've got 4x equals 4. And let's start this off here. We know our coordinate of y is 0, and now we've got 4x equals 4. So we solve this by dividing both sides by 4. Well, that gives us x is equal to 1. So therefore our value of x is 1. We plot those two coordinates, 0 across, 4 up, 1 across, nothing up, and we draw that line in. Notice I've extended the line to the extent of the graph. That's really quite important to do that. So the second equation, we cover up the x, and now we've got minus y equals 2. So we know that our x is 0, but what we've been left with is minus y is equal to 2. To get rid of that minus, we have to divide both sides by minus 1. So minus 1 divided by minus 1 cancels. We're now left with a positive value of y. 2 divided by minus 1 is minus 2. So our y coordinate is minus 2. And that's our first coordinate, 0 across, 2 down. So there we go. And let's find the second coordinate of this line by covering up the y. So again, we're making y equals 0. 2 lots of x equals 2. Divide both sides by 2. X is equal to 1. So 1 across, nothing up. It is there. So we draw our line in. Again, I'm going to the extent of the graph. And finally, we write out our solution. And again, the solution is where they cross. So the solution is x equals 1, y equals 0. Now, if you want to check this, you could solve it algebraically to see. So I'm going to rub some of this out so we can do that as a check. So now I'll solve this algebraically just so you can see. If you remember previously, what we did here was we either get rid of the x's or the y's. Now, I can't get rid of the x's because they're different values. If I take one from the other, I'm still left with 2x. If I add them together, I'm still left with 6x. So in this case, I'm going to get rid of the y's. I do that by adding the bottom equation to the top. Going down the page, 4x add 2x is 6x. A positive y plus minus, that becomes a minus. So y, take away y is 0. And 4 add 2 is 6. Well, to find x, we divide both sides by 6. Therefore, x is equal to 1. Well, that seems to work. And now we substitute this value of x into one of those equations. I will just put it straight into the top one. So I've got 4 times 1, add the value of y is equal to 4. 4 times 1 is 4, add y is equal to 4. I think it's clear to see that y is worth 0 here because I take 4 from both sides. We can see y is equal to 0, and that works as well. So this is just another way of solving simultaneous equations. And if you're not sure graphically, you can double check using the algebraic method. Okay, a couple more to do. Let's go again. Principle is exactly the same. Let's cover up the x so we know x is worth 0. So I'm going to say 0 something. 4 lots of y is 12. Well, 4 times 3 is 12, therefore y is 3. And our second equation, we know that we want to make this second equation the value of y equals 0. So this time we cover up the y. 3 lots of x is 12. Well, 3 times 4 is 12, so x is 4. So there are our coordinates for our line. 0 across, 3 up, 4 across, nothing up, and we draw that in. Okay, the second one now. Again, we cover up the side of the x. In other words, x is 0, so 3 times 0 is 0. 2 lots of y is 9. Well, half of 9 is 4.5, so y is 4.5. So now we have got 0, 4.5. And then this one, we're looking for something 0. So we cover up the y. 3 lots of x is 9. Well, 3 times 3 is 9, so x is 3. So let's go nothing across, 4.5 up. And this one here, 3 across, nothing up. And let's draw that line in. Okay, so here is our solution. Now, I would probably say it's more like there. My lines aren't perfect. So in this case, our solution is x is equal to 2 and y is equal to 1.5. So if you want to check this algebraically, you can do that. The alternative check is to actually put x and y into both of these. So I could say, does 3 lots of 2 plus 4 lots of 1.5, does it equal 12? We're going to check. Well, 3 times 2 is 6. 4 times 1 is 4. 4 times a half is 2. 4 add 2 is 6. And 6 plus 6 make 12. So they are correct for that equation. Let's do it for the second one. So we're saying 3 lots of 2 plus 2 lots of y. And y was 1.5. Do they equal 9? Well, 3 times 2 is 6. 2 times 1.5 is 3. And 3 add 6 is 9. So yes, we know we have now got the correct solution. So a number of ways of checking these. So here's our final question. You'll notice this first equation is written differently. It's written in the form y equals mx plus c. So we can't use the cover-up method here unless we rearrange it, but we don't need to. We can plot the value of c because we know the value of c is the y-intercept, and that is at 0, in this case -4. So that's here. And we know the gradient's 2, which means if I go across 1, I must go up 2. So from that point, across 1, up 2, across 1, up 2, and I carry that on to the extent of the graph. Now I can plot that. Let's look at this second one where we can use the cover-up method. So we know we're going to have 0 something and we're going to have something 0. So cover up the x, because that's the 0 first. Y is equal to 1. Cover up the y. So 3x is equal to 1. So if 3x is equal to 1 and I need to get x on its own, I have to divide both sides by 3. So therefore, x is equal to 1/3. We need to be careful when we draw this one. So our first coordinate is 0 across, 1 up. Our second coordinate is 1/3 across, nothing up. So you do need to be very, very careful here. And then you can plot that. There we go. So our solution is here. So the solution is x equals 1 and y is equal to -2. Again, you can substitute those into both those equations to check them. As always, if you've got something from this video, please like and subscribe. Well done for getting this far.